All right, so in this lesson, we're going to learn how to name and write formulas for molecular compounds. So if we're successful, what we'll be able to do is be able to name and write formulas. And specifically, the substances we're going to be doing this for are called molecular substances. Now, the way that we're going to do this is by using a specific set of rules for naming and formula writing that pertains to molecular substances. Everything we've done thus far has been ionic. Now, why is this important? Well, I'll tell you why. Have you ever heard of the compound dihydrogen monoxide? Maybe, maybe not. My hope is that when you hear this name, it does sound unfamiliar, because that'll kind of prove my point here. Dihydrogen monoxide is in everything that you eat. It's in everything that you drink. It's in your shower. It's all through your plumbing. It's in your house right now. It's at the school that you go to. It occurs in nature. People die from not having enough of it. People die from having too much of it. It is H2O. And when you see that formula, you might think H2O, that is just water. And if I told you all of these things about water, you'd probably think, okay, people die from having too much water. Okay, is that drowning? Okay, people die from not having enough of it. Is that dehydration? And of course it's in all my food and all of my beverages, and it's in my house and at my school. Water is so essential to life. But if I said all of those things about dihydrogen monoxide and you didn't know what I was talking about, it might be a very frightening conversation for you. So the point I'm trying to make here is that you can easily be manipulated by things that you don't have a background knowledge of, by things that you are ignorant of. So my goal with this lesson is that by the end of it, if you can name and formula right, you won't be as easily intimidated or scared by things that maybe you don't recognize immediately. So covalent compounds versus molecular compounds, I've used those words interchangeably. When nonmetals share electrons, they form what's called a covalent bond. So I've got this image here on the right side of my notes that shows the sharing of electrons in this overlap space. I've got atom here on the left and atom here on the right, and in this overlap space they are collectively pooling their electrons together and sharing them. This overlap is what we call the covalent bond. It is extremely strong. It is extremely difficult to break. It's kind of like they're hooked together, these atoms now, because of this shared pair of electrons. Now, covalent compounds are like water. Well, I've got this diagram over here on the left of water. If I were to zoom in on what the heck is water made of, I'd see this repeating shape over and over again. One oxygen and two hydrogens bonded together. Similar to this, one oxygen, two hydrogens bonded together. Now we could call this shape a particle. We couldn't call it an atom though. Why? Because it's made of three atoms. So when atoms bond together, we call those shapes that they make molecules. Now all covalent compounds are made of molecules. So when I talk about a covalent compound, what I'm really talking about is a molecular compound. They are the exact same thing. I can't have a covalent bond without making a molecule. Over here on the right, this picture that I have is a molecule. It's two atoms connected. But I could have 5 atoms connected, like I have in methane. I could have 4 atoms connected, like in ammonia, or even 3 atoms connected in water. And I could have many, many more atoms than 5. But the idea is when you have a group of atoms covalently bonded, they're making molecules. So we could call these compounds covalent or molecular. So let's talk about how the heck do we name. So when we are naming compounds, the first name is going to be the same name as the periodic table. And what I mean by the same name as the periodic table is when I look for that element on the periodic table, I'm just going to use the name that's there. I'm not going to change anything about it. The second name just has to end in "ide." So we are going to change that a little bit. Now, we're going to use this tool called a prefix. What a prefix is going to do is it's going to tell you how many of each atom there are. So if there's one atom, the prefix we're going to use is mono. 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Now this is something you're going to want to know by heart. You're going to want to memorize it. So I would make a marking of some sort to remind yourself, hey, I need to know this by heart. It's not something I can afford to constantly refer back to. So let's get practice putting these rules into place. Now we've got our first compound here, SF6. I've got to find these elements on the periodic table. S is sulfur, and since sulfur is my first element, I don't change the name. F is fluorine, but since it's the second element, I'm going to change the ending to "ide." Now I can worry about my prefixes. There's only one sulfur, so you would think that I'd use the prefix mono, but I'm going to make a little note right here. Mono is never used on the first element. So sulfur, since it's the first element in the formula, it's the first element in the name, I'm not going to use the prefix mono. I'm just going to say sulfur. Fluoride has a subscript of 6, meaning that I need to say there are 6 fluorides. So I'm going to make a little bit of room here to add a prefix. The prefix for 6 is hexa. So now I'm going to move this to be a little bit nicer. Boom. My name for SF6 is sulfur hexafluoride. Let's try another one. I've got H2O right here. H is hydrogen. I'm not going to change its name at all because it's the first element in the formula. Oxygen is my next formula or my next element, but I need to change the ending to "ide." Now my prefixes. There are 2 hydrogens, so I'm going to use the prefix di. Now, oxygen doesn't have a subscript, so I can assume that there's just one. So I'm going to say that I need the prefix mono to communicate that there's one oxygen. Now, if I put M-O-N-O, it would look like I was spelling monoxide, and that doesn't sound very nice. It doesn't sound very professional or chemical. So we just take that extra O out and we name it monoxide. So dihydrogen monoxide is the complete name for this compound. Now this last one, I've got nitrogen as my first element and oxide as my second element. There are 2 nitrogens, so I'm going to use the prefix di, and there are 5 oxygens, so I'm going to use the prefix penta. Now, instead of saying pentaoxide, having 2 vowels, I'll write what I mean down here. Instead of having pentaoxide with A and O being 2 vowels right next to each other, what I'm going to do is I'm going to drop the A vowel so that I have just one vowel, pentoxide, and it sounds much more clean and it flows a lot better. Now I'm going to have you guys pause the video and try these next 3 without me. All right, if you are unpausing the video, I'm assuming you're ready to check your answers. This first one is tetracarbon, heptachloride. The next one is nitrogen, triiodide. Now you might be thinking, what the heck, there are 2 vowels right here. Tri and iodide is an anomaly. This is one very specific exception to the rule of dropping one of the vowels so there's only one. But you won't have to worry too much about seeing that exception. It doesn't happen often. And then the last one is going to be nona-phosphorus pentachloride. All right, so that's gotten us through naming for covalent compounds. I'm going to stop here, move on to the next